Okay, so we're getting you warmed up here for a little homework quiz we're going to have in a bit. And to begin with, the quadratics are the ones where it's something squared. All right, and this, we were learning about how it makes it move to the right or to the left, and this makes it move up or down. Okay, same thing works on the square roots. The stuff on the inside is different than stuff on the outside. Stuff on the inside is the stuff that goes left, right. Stuff on the outside is up, down stuff. All right, so here is a typical problem. If I said y equals x minus 4 squared plus 7, I meant it's a parabola that's been moved where? Right 4. And wait a minute, why is that to the right? Doesn't minus mean normally to the left? But it's on the inside of the parentheses. And if it's inside, you can't trust it. Don't trust anything on the inside. All right? Just like the guy in prison said. All right, anyway, the outside is the up-down stuff. Okay? So outside can be like this too. I just want to stretch your mind on this. Isn't that pretty much the exact same thing as what I have written above it? I just moved the 7 to the front, and it's still on the outside, and so therefore it's still an up-down thing. It's not about being at the end. It's about being on the inside or the outside. This is on the outside, so move it up 7. All right. Back to my pretty slides. All right, inside versus outside. Given f of x is x squared, what transformation was performed to produce the following? It's a fancy way of saying, where did I move the parent function? Or in other words, if you'd rather make it sound more naughty, the mother function. I took the mother function and I moved it where? Left 5. Down 1. Left 1, 2, 3, 4, 5. You've heard of that before, haven't you? All right. I'm going to be doing lots of shifting the mother functions and that. Yeah, okay. Anyway, domain now. Let's talk about domain. Domain is the x's, and I don't have them on here, but you, I hope, know that there's little arrows that means it goes forever this way and that way. Domain is asking about how far does it go this way. If I extended the graph out like forever, how far would my function go? Infinity. So the domain here goes from negative infinity to how far would the graph go that way? Positive infinity. You might just say, well, don't all graphs go forever in every direction? No, not really. Because when we're talking about range here, we're talking about up and down. What's the lowest it goes this way? -1. And what's the highest that it ever goes this way? Infinity. So this one does have a thing other than infinity. It's the -1 there. And I was going to just say, I did something wrong. Does anybody know? And some kids saying, shouldn't that be a bracket? Yes, it should, because it gets to -1. In other words, if I actually put in a -1, the equation will work. So there is a spot where it touches -1. All right, moving on. Let's say you were doing this one. I just want you to make a quick sketch of what it would look like. Tell me its domain and range. This is good practice for the homework quiz we're going to take in a minute. Yeah. So here we go. The graph should be a square root shape like that, generally. That's really rough. And then it's generally moved where? Well, that's 1 to the what? And then what's that? Up 4. So I'm going to make it more specifically. Let's see if I can do this right. 4 goes with 2, so there. And 9 goes with 3. So there, that's pretty close. And then the whole thing needs to, I made it in 2 parts, so it's not going to move together. All right, it needs to move 1 to the right, and then up 4. 1 to the right, up 1, 2, 3, 4. I'm doing both parts because, yeah, I can just make it match. There, did your graph look something like that? And then the domain. The domain is, if you look at the graph, it's how far does it go this way? And you can't just say it goes forever this time. It stops. It stops at where? 1. 2, does it go to infinity this way? Yes, it does. And, oops, sorry, that's supposed to be an infinity. And yes, there's supposed to be a bracket on the what? The 1. Okay, the next one's the range. How low does it go? 4, bracket, to what? All right, goes to infinity. All right. Any questions about that? That is called interval notation. for domain and range. Fancy sounding words, but it's really not hard. The hard part maybe would be to do this if you didn't have a graph, if you only had a function. But I bet you can look in the function and see where the 1 comes from. Doesn't it make sense that the 1, since it deals with left and right, would be in the domain? That makes sense to you? And if you just look at this, it's the up and down thing, and it has to do with the range, and the range is up and down stuff, so that makes sense that that would be in there. All right. If I had asked you to write an equation for this, except translated up 4, well, the parent looks like this. Up 4 just means plus 4. These are pretty easy. And even if it's got 2 parts, square root translated up 5 and left 2, well, the left 2 would be like this, and the up 5 would be like this. And those are pretty easy. But what if it starts as this, and then they ask you to put it from there up another 7? Kids get confused because they say, well, I've already got a 5 there, so maybe I should change it to a 7. No, if you're going to go up another 7, yeah, this actually adds another 7 like this, and so the total would become 12. And if I asked you to also move it down 6, right 6, it's currently going left 2, and if I said to go right, move the whole thing right 6, then I can't just like add the 6 to that, can I? What do I do to go right 6? If it's already left 2, do I replace this 2 with a 6? That doesn't make sense. So then a net effect would be, it would change this from a plus 2 to a what? To negative 4. Okay, so my new answer in this case would be y equals x minus 4, and then those guys together makes plus 12. All right. There's a kind of a review of where we are so far. And that's the kind of stuff you'll need for the homework quiz. But now we're going to go a little bit farther and make sure you understand how to do these kinds of problems. Now, we did do some of these yesterday. We talked about Friday, but they bear repeating because it's a little bit tricky. It looks complicated. But if I simplify it by saying that's the function, and if I told you to do f of 8, you'd understand you stick an 8 in, all right? 2 times 8 is 16, plus 1 would be 17. It'd be really easy. But what if I want to do f of, what it says here, x plus 5, minus 5? Then I want to stick an x minus 5 wherever there used to be an x. I drop that right in here. So my best advice on this kind of a problem is to rewrite it with empty spots where the x's are. 2 empty spot plus 1. And then drop in whatever they're telling you to drop in. They're telling me to drop in x minus 5, so I'm going to put x minus 5 and x minus 5. And now if you think of this like a big equation, it seems like you should distribute the f out. Don't ever do that. This is f of x minus 5. You don't do anything to that. It's telling you the answer, and it's over here. There's the answer. So I'd say it was 2x minus 10 plus 1, which is 2x minus 9 is your final answer. So you start with the function. You stick in what they tell you, in for the x, and don't do the left side of it, just the right side of it, and get the answer. Would you please try that one on let's do number 3, actually. Go to number 3, down here. See if I can get that one right. Start by writing down this function. And I'd recommend you put an empty spot where the x is. Okay, I started by putting an empty spot wherever the x's were from this function. And then I'm going to drop that in. But then I actually have to multiply it out, and final answer is negative 4 times x is negative 4x plus 8. Raise your hand if you had that one right. Okay, good. Now, what happens if you have like this? It gets even more messy. What do you think you should do first? Do this parentheses part and drop it in where? Yep. If I do that first, and drop it actually in both places, look at f of empty spot equals 2 empty spot, and then I drop in x plus 4, I will know that f of x plus 4, don't ever do any more on that side, is equal to 2x plus 8. Now, what do I do now? Yeah. The original problem was to figure out 3 plus that, right? So here's f of x plus 4 right here. That I have just figured out is 2x plus 8. So I can put a 2x plus 8 right there. And I'll have 3 plus 2x plus 8. And then you just have to simplify that and you have your answer. So the final answer on that one would be what? It was plus 11, I think. 8 plus 3 is 11. All right. Would you guys please do number 4 right now on your paper? Different part of your brain for doing than for watching. Try number 4. All right, here we go. I'm going to start by figuring out what f of x plus 3 is. So I'm going to drop that into this function, except with an empty spot. So I'm going to drop in x plus 3 and x plus 3. And now I have this is equal to negative x minus 3. I'm going to say distributed out the negative. Some people probably forgot that last little negative there. And I'm going to now say f of x plus 3 is that, so I'm going to drop that right here, and my final answer will be negative 4 plus negative x minus 3, but I got to simplify it. And so that makes, let's see, if I put the two negatives together, it makes it negative x minus 7. Raise your hand if you got that one right. Excellent. Okay, had somebody walk in the room there, so I paused. I'm back now. So are you getting this? Okay. Basically, you start with your function, you leave an empty spot where the x is, you drop in whatever they tell you to, and then if they have something extra, like 3 plus at the beginning, you just put in the 3 with whatever you got for this part. All right. Now, the last part here is what transformation happened. And I want you to stretch your mind into thinking about this as a move to the left, a move up, move down, that kind of thing. So what you do is you look at the original function, which is right here. And if I do this to it, do you get how I'm doing something to the inside? Because the number I've got is by the x there. So I'm affecting the inside. And if I'm doing the inside, that's left-right stuff. So what happens on that first one? It moves right 5. Whereas on this one, it moved it which way? Left 4. How about this part of it? That part's up 3. So I took my original function here, and I moved it left 4 and up 3. Would you please write for me what this one did to the original function? Just write L this and R that, or up this. Just a quick, what did it do? I need to keep you writing. Hopefully you said left 3 and down 4. Raise your hand if you said it right. Good. And I think we're enough on that. Now, sometimes pictures can be confusing because they say, okay, write in function notation where the function got moved to. Well, this hasn't been moved anywhere. That is the function. Now, if I take and move and make a new function, it's just like it, except it shifted one over to the right. The purple one is the child function, and the blue one is where we start, the parent function, or the mother function. And if I take the blue one as the parent, then I move to the right one. So how do I say I move to the right one? I write y equals f of x, but then I go right one. How do I do that? Yep. You don't have to know the function. You don't have to know that the function is 2x minus 7 or whatever. You just have to know that the function, f of x, has been moved. So if I wanted to start with this, and I say I want to move my function up 2 and right 3, that's how I write my function notation for it. I don't have to have the original. I just have to have a general way of writing it. All right, so now I'm going to move this thing somewhere, and I want you to write me one of these things. Okay? So write me one. If the parent starts here, and then I move it here. Your answer should have an f of x that's been enhanced. Did you say x? Is it minus or plus? Minus, and it moved over how far? And then how far up did it move? Stuff's on the outside you can trust, so use a plus. All right. So what if it's the other way around? What if they say, here's this, and I give you this direction. I want your new function to be this. What would you do? Yep. Now, on a smartboard, it's awesome because I can go 1, 2, 3, 4, 5, and then up 2, and it's really easy to just move it, okay? You won't have that on your test. You will have not anything like that. You just have a picture, and you'll have to put the new picture on there. So what I'd do is move points, like this point right here, and this point right here. If I just kind of, oh, and maybe the middle point of the whole thing right there. If I take those points and move them to the right spot and then connect the dots, I'll be okay. All right, maybe I should throw in a point right here. So I'm going to move those 5 to the right and up 2. 1, 2, 3, 4, 5 to the right and up 2. 1, 2, 3, 4, 5 to the right and up 2. 1, 2, 3, 4, 5 to the right, up 2. 1, 2, 3, 4, 5 to the right, up 2. And then I just see if I can connect my dots. And is it kind of looking the same? Yeah, kind of. Like that. Okay, so moving the picture over is a little harder than telling me this part. That's pretty easy. All right, you'll have a couple of those on your homework for today. Now, one last thing I want to do is talk about domain and range of this thing. Now, this thing is drawn purposefully, as in, if it doesn't look like it touches something, it doesn't touch it. All right? I want you to tell me, just for the blue one, what's the domain, what's the range? Write it in interval notation. Give it a shot. Even if your arm is broken, use the other arm. But Mr. Server, what if my other arm is holding a cell phone? Then what? Okay. The domain on this thing is how far this way and how far that way. So how far does it go this way? I'll help you count it because it's hard from the back row sometimes. 1, 2, 3, 8. 8 to the left. How do I write that? Domain is from -8. And it's a bracket, you're correct, because it does touch it. 2, does it go forever this way? No, it stops where? And does it get to 2? Yes. The range is from this way, to, which is how low? -2, but does it touch it? No, so it's a curve. Curve or parentheses, whatever. And then it's the highest it ever goes, this way. And it does touch that bracket. Okay? All right. So remember on domain, it's always this way to this way. Range, it's always this way and this way. And I think the little arrows kind of helps to figure out where we're going, because otherwise it can be confusing. All right. The blue graph is the original. Write an equation for the transformed purple graph. Just sum it up. See if you can write the equation for this thing. The purple one. If I'm seeing how far down this went, I'm going to count it out and go. Went down 1, 2, 3, 4. One second, I went down 5. And take this pointy compared to this pointy spot. And it looks like it went over 3 to the right. So give me a final answer. Yes, sir. All right. Any questions? Feel completely ready? You get what I just talked about? All right, then we'll have a little homework quiz. And you'll have so homework is to finish the assignment that we gave you yesterday, which was, what was it called again? Anyway, see, just in case anybody's following along at home, you know which assignment this goes with. It is Higher Algebra Transformations Worksheet A. Just finish that one up. I am also handing out this little orange thing, practice on showing your steps. And those are due tomorrow.